Okay, so this is Dr. Dan back. Now that we have went ahead and prepared all our tendons, we need to go ahead and get ready to do the testing. And so I've already done a bunch of the work that is listed in the first couple steps of the protocol, which is to turn on the computer, turn on the Instron machine, bring up the Blue Hill software. And so this is what happens when we're at this Blue Hill software. And there's a couple things we could do. We could do a test, we can set up a method, we can set up a report. Really, we're just going to be messing with setting up a method, and then we're going to go and do the testing. We're going to do 3 different types of testing today. So number 1, we're going to test for hysteresis. So we're going to pull it up a certain distance, and then we're going to go back a certain distance and just measure the stress and strain over that distance. The second thing we're going to do is just a stress relaxation. So we're going to pull to a certain distance, a certain strain, and then we're going to just let the machine stay at that strain and measure the force. And so we'll see the stress over time decrease. And then finally, the last thing we're going to do is just pull some of these to failure, just so you can see what happens when we pull to failure. What we'll do is we'll start making a method. I'll go to New Method, and we'll do the easy one, which is just pull to failure. So I'm going to set my tension method. I'm going to create it. Okay, a lot of what this does, this whole software was designed to do a lot of analysis and produce all the graphs for you immediately. And that way, if you have like 100 samples, it's pretty easy, and you could just get the graphs in the Blue Hill software. But that's not what we want to do. We usually want to overlay. We want to do some analysis on our own. And so we're not going to really use most of these settings in the Blue Hill software. What we are going to use is the control. Okay, we're going to want to control what we're doing. And so we want to control extension at some rate. Okay, and so we need to think about what rate to pull at. If you pull too fast, it'll give you different results than if you pull too slow, right? And so usually when you're doing mech testing of tissues, you want to usually pull pretty slow. And so if I'm thinking about this, I could just think about my tendons themselves. Like maybe I want it to be about a minute of pulling before it breaks. And so it is really slow, but we're collecting a lot of data. And so I don't know when these will break. I'm thinking no more than 50% strain, right? And I went ahead and measured a bunch of the tendons just to get a feel how long they are, somewhere in the 20 to 30 to 40 millimeter range. So if I want 50% strain on a 30 millimeter tendon, that would be 15 millimeters in a minute. Okay, so if we're pulling it to 50% strain, it would take us a minute to get there. That's a pretty good number to start with. And so it's just going to keep pulling at 15 millimeters a minute, okay, until we get to the end of test, which is the next thing. And so one of the criteria that we use to detect breakage is this rate of load. So if the load drops off by 40% really quickly, it means it's broken and it will stop the test. And so I can leave that there. That's a pretty good starting place. The other thing I want to do is make sure we protect the load cell. The load cell is what measures the force on the machine. And if you overload the load cell, you could break it. And so we always want to set some sort of test condition to stop before the load cell. So my criteria is load, and the load cell is 100 newtons. So it's capable of measuring 100 newtons. You go over that, you're going to ruin the load cell. So we want to make sure it stops before it gets there. And so I'm going to say stop the load at 80 newtons. The trick here is we're doing it in tension. And in tension, the load cell is actually pulling a negative. So we want to say if it gets to negative 80 newtons. And then we don't really need to set an end of criteria test. Basically, this is going to pull until it breaks or until it reaches our load limit, which we hope it doesn't reach our load limit. But this is just to make sure it protects our load cell. Okay, and really that's all we need to do. We can, like I said, these are all set up to set up the results. But what we want to do is make sure we export raw data. And so we're going to just export time, extension, and load, which are these 3 parameters already there. And so when we go to reports, we need to make sure we tell it to export raw data, which is over here. And so it's not normally clicked. We want to export it. We don't want it in this raw format. The CSV format is usually best. Okay, and it's going to export all those things we asked for. If we wanted additional things to export, we could put those here, but it's going to export everything that we had already said we wanted in the raw data. Okay, so now I can save and close this. I'm just going to save it on my desktop to make it easy to find. I'm going to say pool to failure is the name of this method. Okay, so we have one done. The next easiest one to do is actually the stress relaxation one. Okay, so I'm going to do another tension method. I'm going to create it. Again, we're just going to go straight to the control. So we want to pull an extension, okay, for some amount. Again, I think 15 millimeters per minute is good. What we're going to do here, though, is after we reach a certain amount of extension, we're just going to hold it constant. We don't want to pull anymore, and we just want to wait. Okay, so I'm going to hit ramp 2. My ramp 2 is then 0 millimeters per minute extension. Okay, and then how do we know we want to change over? That's what this is, a change over from 1 to 2. And again, I have to pick an extension value to change over from 1 to 2. And so I don't want to pull too far, right? I definitely want to get past the toe region, but probably not get into the where it's breaking. So again, if my tendons were 20 millimeters at the smallest, like I think if I pull 20-ish% is strain, that's probably plenty. So let's go to 4 millimeters. Okay, so we're going to pull for 15 millimeters per minute until we get to 4 millimeters, and then we're going to hold it. We're going to pull at 0 millimeters per minute, which means hold. Okay, but we still need to say, okay, what finishes the test? So we go to end of test. Again, we could leave this rate of load on there, that's fine. I'm also always going to put the load at 80 newtons, minus 80 newtons on here. And then finally, the real end, so I don't expect either of these to happen, because I don't expect it to break, I don't expect it to get near the load, but the real end of test is going to be time. And so how long do we want to hold this thing? Okay, and so first thing we need to know is for 15 mils per minute, it's going to move 4 mils. Okay, so that's going to get us about, a quarter of a minute, so somewhere in the 15-second range. And then we want to hold it for a certain amount of time. And I'll say holding it for a minute is probably good. So I'm going to change this to seconds. So we're going to hold it for a total of 60 seconds. So 15 seconds to get there, plus 60 seconds to hold. We'll end the test after 75 seconds. Okay, and so that's all we need there. Again, I need to go down to raw data. We're exporting those things. My reports, I want to make sure I export the raw data in CSV format. And that's all I need to do. I'll save and close. And I'll call this one stress relaxation. Okay, so we have 2 of the 3. The last one we want to do is a new one. This one is a little bit different because it's actually a little bit more difficult to get this hysteresis. The generic tension method doesn't work really well. So we can go down to our drop down and we want to find this test profiler method. Okay, there is this relax creep method, which I just prefer to use the test profiler method. I feel like I have more control over things. So I create a test profiler method. Again, it's going to be the same setup, only this time my control is a little bit different. It's a profile. Okay, it wants me to save this, so I'm going to just save it first. We're going to call this hysteresis. Okay, and so what it's doing is it's like you can set up a profile. So like if you wanted to do triangle waves, if you wanted to do sine waves, you could do a lot of different things here. Okay, really we want to do a triangle wave, right? And so I can just click on this triangle that we tell it what we want to do. Okay, and we tell it our minimum, our maximum, where we're going with these, right? And so right now it's max is 0. Its min is 100, so you can kind of see how it sets up this triangle a little bit. That's not really what we want to do. We want to set our max to some millimeters. Again, we talked about 4 millimeters before, and then my min is 0. My rate in millimeters per minute, Again, if I want to be consistent, maybe I'll just stick that to 15 millimeters per minute. Okay, this test will be fairly quick, and I do want to do one cycle. Okay, if I wanted to repeat doing triangles over and over again, I could. So this is hard to see because the numbers are so small. You saw when it was 100, it didn't go very down much, but this line is actually a triangle in there. Okay, so we're going up to 4, we're coming back down to 0 at a rate of 15 millimeters per minute. So I can save this test profiler. Yes, save changes in profile. We don't need to worry about the end of test too much. Again, just in case it breaks, just in case the load gets to be above that minus 80 newtons, that's all we need for that. But the rest of it is being controlled by the this profile. Okay, we want to make sure we're exporting raw data. And we can save and close. Okay, so we have our 3 tests set up.